Bernoulli put pressure, velocity, and elevation into equation. So in Bernoulli equation, Bernoulli get the pressure of the fluid, velocity of the fluid, and the height of the fluid get from a certain point. It will look like this. This will be our pressure. This will be our velocity, and this will be the height that Bernoulli get. So we have pressure 1, velocity 1, and height 1 to pressure 1, pressure 2, velocity 2, and height 2. So P here is the static pressure plus 1/2 the dynamic pressure, density, velocity squared, plus the pressure of gravitational acceleration and height is equals to constant. So in Bernoulli's equation, if something increases, something decreases. And there's also a fixed value in the equation. This fixed value na siya guys, bali magiging yung equation natin is P1 plus or P1 or pressure 1 plus 1/2 density velocity squared 1 plus density gravitational acceleration height 1 is equals to pressure 2 plus 1/2 of density acceleration squared 2 plus PGH or density gravitational acceleration H2 or natin sila ng value guys. Itong pressure 1 natin, example sabihin natin na equals to 280 atmosphere. Ang ating velocity V1 is equals to natin 2 meter per second. Ang height natin sa H1 is 5 meters. Ang height natin sa H2 is equals to 10 meters. Ang V2 natin ay 2 meter per second. So ngayon, ang hahanapin natin ay pressure 2. Sa example natin ay hindi na same lang yung velocity since hindi naman nag-change yung diameter ng itong diameter dito. So dito sa dV over dt equals A times V equals constant. So yung A1 V1 equals to A2 V2 ay kung yung hindi mag-change yung A1, hindi rin mag-change yung V2. A2 V2. So pag ganun, yung velocity natin ay walang changes, 'di ba? So magiging constant ngayon itong velocity. Yung dito na part, magiging constant 'yan. So hindi na natin siya isasali since equal lang naman siya. Since gano'n na nga, constant itong dalawa means that equal lang sila. So para since yung nagkaroon tayo ng increase dito sa height 2 kaysa dito sa height 1, itong pressure 2 natin ay kailangan mag-decrease para maging balance yung equation natin. So meaning na mas mababa yung pressure 2 kaysa sa pressure 1. May value na sila, i-solve natin itong equation pag nag-increase yung height. So since constant yung density velocity squared natin, ay ika-cancel out natin yan sila guys sa equation. So pwede natin siyang tanggalin itong dalawang to, ganyan. So ang pagsulat natin sa ating equation ngayon is pag i-simplify natin, P2 equals P1 plus PGH1 minus PGH2. Pag i-simplify pa natin yan sila, itong pressure 2 is equals to pressure 1 plus density in gravity height 1 minus height 2. So bakit P2 ito? Kasi P2 yung hinahanap natin. So since nakuha na natin yung formula natin, i-substitute na lang natin siya. So P1 natin is 2 atmosphere. P yung density is density of water. So yung density of water natin is 1,000 kilograms over cubic meter. And yung G, gravitational acceleration, ang value nun ay 9.8 meter per second square. Tapos yung height 1, 5 meter minus height 2, 10 meters. So, i-multiply lang natin ito. I-multiply dito, then i-multiply dito. Then, makukuha natin yung negative 49,000 N over meters square. 1,000 kilograms over cubic meter multiplied by 9.8 meter per second over 1. So i-multiply lang natin yung 1,000 kilograms sa 9.8 meter per second at yung cubic meter sa 1. So after nitong multiply, makakuha tayo ng result na 9,800 kilograms per meter per second over cubic meter. Then i-multiply natin ito siya sa negative 5 meter over 1. Negative 5 meter is yung sum nung 5 meter minus 10 meter. So, i-multiply lang natin yung 9,800 kilograms per meter per second into negative 5 meter. At yung kalabasan niya is negative 49,000. And since meter cube yung sa baba at meron tayong meter dyan sa taas, makakancel yung isang m dyan, magiging meter square na lang. So, instead of cubic meter, bali negative 49,000 kilograms meter per second over meter square instead of cubic meter. And sin yung kilograms meter per second ay pwede nating isulat as N. Yung kinalabasan niya ay maging negative 49,000 N over meter square, which is a sign ng Pascal. Yung N is Newton. So, itong N over meter square na to ay Pascal. Ito yung parang Pascal natin. So yung Pascal, yung bale 2 atmosphere, tapos yung ito na to ay i-convert natin to as atmosphere. So i-convert natin yung Pascal into atmosphere. So let's multiply negative 49,000 Pascal multiply by 1 atmosphere divided by 101,325 pascals. So makakancel yung Pascal, matitira yung atmosphere. Then i-divide lang natin, makukuha natin yung 0.48 atmosphere. Kung maging kalabasan niya ay 2 atmosphere minus 2 atmosphere minus 0.48 atmosphere is equals to pressure 2 equals to 1.52 atmosphere. Water flows through a circular pipe with a constant radius of 10 cm. The speed and pressure point at A is 4 meter per second and 250,000 Pascal respectively. The question is, what is the pressure at point B, which is 10 meter higher than point A? So sa pressure 1 natin, 250,000 Pascal. Sa pressure 2 is unknown pa rin. Yung velocity 1 and 2 natin is 4 meter per second, same lang sila. And since yung walang sinabi na height, pero sinabi lang na 10 meters higher, let's start sa H1 na 0, tapos 10 sa H2. So since constant naman yung velocity, kakancel natin siya. So ang matitira natin ay P2 equals P1 plus PGH1 minus PGH2. Simple form, P2 equals P1 plus PG multiply by H1 minus H2. Then, i-substitute na lang natin sila. Ito yung pagka-substitute. P2 equals to 250,000 Pascal plus 1,000 kilograms over cubic meter multiply by 9.8 meters per second squared multiply by 0 meter minus 10 meter. So, isolve na natin siya. Makukuha natin yung 250,000 Pascal plus 9,800 kilograms meter per second over cubic meter multiply by negative 10 meter. So, yung cubic meter natin, makancel yung isa dyan, maging meter square na lang siya. Since dun sa 10 meter natin, meron isang meter doon. So yung kinalabasan nito is 250,000 Pascal minus 98,000 kilogram per meter second over meter square, or for short, Newton over meter square, or we can derive it as Pascal. And for the final touch, let's just subtract 250,000 Pascal minus 98,000 Pascal. Then our pressure 2 is 152,000 pascals.